Okay guys, this is week 13. The first IXL that I'm going to ask you guys to do is S1, identify linear functions from graphs and equations. So a linear graph looks like this. So as long as it is a line, right? If the line is going this way, if it's going that way, if it's going this way, or if it's even going this way, no matter what, these are all lines. These are all linear. Now, nonlinear would be curves, right? So these are not constant graphs. We know that a constant graph is a line, and when it's not constant, it's a curve. So linear functions are lines, right? Is the function f of x equals negative 8x to the 10th power plus 1 linear or non-linear? So the way that we figure this out is we know that slope-intercept form, okay, is mx plus b, okay? So mx plus b. So notice that the x has no exponent. There's nothing right here, right? And it's just x. So if we're looking at f of x equals negative 8x to the 10th plus 1, right? We know that the 8 is our m, the 1 is our b, but our x, right? The x has to stay the same. And we can see right here that x is to the 10th power, therefore making it non-linear. Okay? This graph is not a line, right? It's a curve. Therefore, it doesn't have a constant rate, and it is non-linear. Okay? This one is a line, therefore, it is linear. Okay? So we kind of get it. This is kind of how you do it, right? Linear, non-linear, non-linear. See, even if it's dotted, it's still shaped as a line, right? We can see that if we connect the dots, it's still a line. So it is linear. Same slope, right? This graph, is it in mx plus b? Well, it's 5 to the x plus 3 halves. That is not in the correct form, right? So it's non-linear. And finally, we have x plus 1 over 10, right? We have h of x equals x plus 1 over 10. And if we look at mx plus b form, right? The 1/10 surface as our b, okay? Our m is the number in front of x, which is 1, right? And x is still x. Therefore, it is indeed linear, okay? So now we move on to identify linear functions and tables, okay? So the way that we know a linear function is linear is if it has a constant rate. So if we're looking at our x's, right, it goes 2, 3, 4. So these are going up by 1, right? That's a constant rate. And then this side, 2 to 12, we add 10. We add 10 to get there. 12 to 8, we add 6. Is this constant? Is this the same thing? It is not. Therefore, it is non-linear. So we see that our x's go 9, 10, 11. So let's go from 5 to 8. So 5, 6, 7, 8. So we add 3. 8 to 11. So 8, 9, 10, 11. We add 3, right? This is constant. The other side, we're adding 1, right? We're adding 1. Therefore, it is linear. Okay? So that's kind of how we do this one. So we see here that this one we are adding 6. We are adding 6. Over here, we are adding 2. But now we are adding how many? We are adding 10. -4 to 6 is 10. Therefore, it is non-linear. Okay? Let us move on to our next one. And this one you have to type in our quick code. KCC. Write a linear function from a table. Okay? So, the way that we do this is we're going to look at these numbers. These move up by a constant rate, 1, 2, 3, 4, okay? And 12 to 13, 13 to 14, 14 to 15, all we're doing is adding 1. We are adding 1 each time. Adding 1, okay? So, that number is going to go in the front. So, we're going to put it in slope-intercept form. So, we got y equals mx plus b. This number is going to be m, our slope, okay? So we're going to put m as 1, x plus our b. So now we're going to see our b. If we multiply 1 by 1, we get 1. What do we have to add to 1 to get 12? Well, we add 11. We add 11 to get 12, right? 2 to 13, we add 11. 3 to 14, we add 11. Okay, so our b is the number we add to get to our y. Okay, so our equation is y equals x plus 11. We don't actually need this one. Okay, next problem. The x's are adding 1, 3, 4, 5, 6, okay? And we go up by 1. Okay, we're going up by 1. Okay, so our y equals 1x plus, okay? So if we look at our x's, 3 plus what equals 0? Well, we're going to actually have to subtract. It's actually going to be something minus. So we're going to subtract 3. 3 minus 3 equals 0. 4 minus 3 equals 1. 5 minus 3 equals 2. So our number in the blank is 3. Okay. So here we are adding 9 plus 3, 12 plus 3, 18 plus 3. That's our m. That's the number in the front. Okay? And then we know if we look at x, so 3 times 3, that gives us 9. We look at 4 times 3, we get 12. 5 times 3, we get 15. We don't need to add anything else.